So let's actually do this question. Now remember, from the past videos, we have to highlight the important stuff. So let's go. So a force acts at a distance. Now we realize already, they say a distance. They did not say moment arm or lever arm. So we know that this is not perpendicular distance, right? A distance of 6 meters, 0.6 meters, 30 degrees from the horizontal. Calculate its perpendicular distance. So the next step would be to draw a diagram. So they say horizontal, so that means we have a horizontal. And let's put a fulcrum, right? And we'll continue the horizontal going across, like what we do in these examples here, right? And then they said that it acts 30 degrees from the horizontal. So we have 30 degrees here. And it is 0.6 meters long. So there's what the force doing here, right? So now they want us to calculate the perpendicular distance. So what we can do is we can break it down into one of these triangles, right? So we'll do this triangle first, and then we'll go into this one. So we have 30 degrees here and 0.6 meters, right? You see in the vertical component and the horizontal component, right? Now we will label it, because remember to use sine rule. Sine rule is A over sine A is equal to B over sine B is equal to C over sine C. So we need these variables, right? So let's just label the triangle. So I'll put C here because we know C is always along this side. And I'll just put A here and B here, right? So what I would use would be, I'll just use these two, right? Because we know that B would be this angle here, A would be this angle here, C would be this angle here, right? And well, we need to find B because we're looking for the horizontal component, right? So we're going with B over sine B is equal to C over sine C, right? And we could transpose this so that B sine C is equal to C sine B. I really hope that that's not confusing you guys and you're following, right? And so B would equal to C sine B over sine C. So we could plug in the values, but before we do that, if you realize we don't have B, but because we have 30 degrees, we have this 90-degree angle. This angle here would be 60 degrees. So B would be equal to C, which is the 0.6 meters, by sine B, which we just got, which is 60, over sine C, which is 90. Right? So we could just calculate this. Sine 60 is equal to that multiplied by 0.6, which is equal to 0.51. And we know that sine 90 is 1. So that would be around 0.52 meters, right? Let me just double check. Sine 90. Good. Right? So we know that B is 0.52 meters, and we used B to label the horizontal component or the perpendicular distance. So the answer to this question would be that the perpendicular distance D would be 0.52 meters. Now remember, we could use this triangle too, right? So I'm just going to do it smaller so that it fits on this page, right? So we can draw over the diagram and we could find the perpendicular distance another way. So we continue the horizontal we draw the line up. We know this is 0.6 meters, and we know this is 30 degrees, but we decide we want to do it the other way. So we run this line up here from the fulcrum, and then we attach it to the line of action of the force. So there's the angle we're working with here. And we know that this triangle would be looking something like this, right? So we have the right angle here to give us 30 degrees, but we know that as in this one, we have to minus this 30 degrees from this 90-degree angle because we want what in this triangle, right? And we'll get 60 degrees, right? And so we know that this side is 30 degrees, right? Right. So now we're using sine rule again. But first, let's label the triangle. We know that this is C. This is capital C. I'll put this as A. This could be big A. I'll put this as B. And this would be right. So now we're working with A as the perpendicular distance, right? We can see that here. So we'll use A over sine A is equal to C over sine C. So if we transpose, A would be equal to C sine A over C sine A over sine C, right? So let's add in the values. We know that C is the same 0.16, C equals 0.6, sorry, where I got a 1 from, boy. So we know it's 0.6 meters by sine A, which is 60, over sine C, which is 90. Now we realize we get the same formula, so the answer would therefore be the same. So we're seeing that you can use two different ways to find the perpendicular distance, and both would be correct. So this one would also be perpendicular distance in answering the question would be 0.52 meters, right? So I really hope that you all understand what I did in this video, and that it would make calculating perpendicular distances much easier. In the next video, I'll go more into the vertical and horizontal component so that you could use, and I'll also be including a practical example so that you could visualize everything. And I would be using these ways in calculating perpendicular distance as well, just to cement everything. So you know you're doing physiotherapy, so that's why the practical example is there, so you know that you're not just doing this course for so, but it actually has a purpose, right? So like I said, if you enjoyed this video, sorry, I didn't say that. Like I said, make sure that you rewind, you pause whenever necessary, you go through this over and over again, you cement what was said, understand the basics, so that when you have to do these tough questions coming, you know your basics, right? So guys, if you like this video, make sure to leave a thumbs up, subscribe to the channel for more videos like this, and yeah, comment down below if you want anything explained further, if this was satisfactory, etc, etc. So that'll be it for this video, guys. See ya.